For years, when investors analyzed big tech earnings, they focused on familiar metrics: user growth, advertising revenue, cloud adoption, subscription expansion, device sales, margins. Energy barely entered the conversation. Electricity was just an operating expense, important but not strategic. That has changed. In 2026, big tech earnings are increasingly tied to energy availability, not because companies are becoming utilities, but because AI has transformed electricity from a background cost into a growth constraint. Let's start with the obvious shift. AI is energy intensive. Training large-scale AI models requires enormous clusters of GPUs running continuously for weeks or months. Inference, delivering AI services to millions of users, requires constant computational throughput. Add cooling systems, networking hardware, redundancy layers, and storage infrastructure, and modern data centers consume staggering amounts of power. Some new AI campuses request hundreds of megawatts of electricity. Over time, certain multi-site expansions approach gigawatt-scale demand. That's city-level energy usage. Now here's the key point. If a company cannot secure enough power, it cannot deploy enough compute. And if it cannot deploy enough compute, it cannot scale AI services as quickly as demand requires. That directly affects revenue growth. Cloud providers, for example, depend on expanding data center capacity to support enterprise AI workloads. If grid interconnection approvals are delayed, if transmission upgrades lag, or if regional capacity is constrained, new server clusters sit idle or are deployed more slowly than planned. That slows revenue ramp-up. In previous cycles, scaling cloud infrastructure was mostly about ordering more servers and building facilities. Now scaling depends on megawatts. Second, energy availability influences geographic expansion. Certain U.S. regions have become AI data center hubs, but grid stress in those areas is rising. If utilities cannot guarantee large new loads quickly, companies must look elsewhere, often at higher cost or longer build timelines. Location strategy now depends on power capacity as much as fiber connectivity. That shifts capital allocation decisions. Third, energy pricing affects margins. Electricity is one of the largest operating expenses in AI data centers. If regional power prices rise due to demand spikes or fuel volatility, operating margins compress. Companies that lock in long-term energy contracts gain cost predictability. Those exposed to fluctuating rates face earnings variability. Energy strategy now influences gross margin stability. Fourth, investor expectations are enormous. Markets have priced in sustained AI-driven growth for major tech firms. If infrastructure deployment slows because of power constraints, revenue growth could decelerate. That makes energy not just an operational concern, but a valuation driver. Fifth, renewable energy commitments add complexity. Many tech companies have pledged carbon neutrality or 24/7 clean energy sourcing. Meeting those commitments while scaling AI infrastructure is challenging. Renewable generation is expanding, but integrating intermittent sources with always-on AI workloads requires storage or backup systems. Balancing sustainability targets with capacity expansion affects capital spending and timelines. Sixth, power reliability influences service stability. AI-powered services are increasingly embedded in enterprise operations. Outages or performance degradation due to grid instability could impact customer trust and contract renewals. Reliable energy underpins service-level agreements. Seventh, regulatory frameworks affect expansion speed. Permitting new power plants, transmission lines, or substations takes time. Community opposition to large data centers or energy infrastructure can delay projects. Tech companies are now directly engaging with utilities and policymakers to secure capacity. Energy policy discussions increasingly intersect with earnings calls. Eighth, vertical integration is expanding into energy. Some tech companies are investing directly in renewable projects, battery storage, and even nuclear partnerships. Securing dedicated generation reduces exposure to grid bottlenecks. Energy ownership becomes part of competitive strategy. Ninth, energy efficiency improvements affect cost structures. Next-generation AI chips aim to deliver higher performance per watt. Improving efficiency reduces energy cost per computation. That improves margins. Hardware innovation and energy economics are now tightly linked. 10th, interconnection queues are real bottlenecks. Across parts of the U.S., grid operators face long backlogs for connecting new large loads. Even if a data center is built and equipped with servers, it cannot operate at full capacity without grid approval. This delay impacts revenue timing. Timing matters in public markets. 11th, competition intensifies the race for power. If one company secures regional capacity faster, it can deploy AI services sooner. Energy access becomes a competitive moat. 12th, macro energy trends influence forecasting. Fuel prices, natural gas supply, renewable generation growth, and infrastructure investment all shape electricity costs. Tech earnings are now indirectly tied to broader energy markets. So what does all this mean? It means that AI has turned electricity into a core input of digital growth. Energy is no longer just a cost line item, it is a scaling constraint. If power infrastructure expands smoothly, AI-driven earnings can grow rapidly. If grid bottlenecks emerge, growth slows, regardless of chip availability. This is why energy executives and tech CEOs are increasingly appearing in the same conversations. Why power purchase agreements make headlines. Why nuclear partnerships are back on the table. Because in the AI era, compute equals revenue, compute requires power, and power availability now directly influences how fast big tech can grow. In previous technology cycles, bandwidth defined scalability. Today, megawatts do. That's why big tech earnings are now tied to energy availability, not metaphorically, literally.